So today we're looking at area of a trapezoid and area of kites and rhombi. All of those have perpendicular diagonals. So I'm going to write the formula, then I'll explain it. The area of a trapezoid, area equals half the sum of the two bases times the height. And the reason this is because we want to take this trapezoid and kind of think about making it into a rectangle. It has essentially the same formula as the area of a rectangle or area of any parallelogram, but it's just looking a little differently. If you can think about like finding the midpoint of each of those, if you kind of take this triangle off here and rotate it around, and if you were to like stick that area up there, and if you take this triangle and rotate it around and put that area up there, you would have this nice little rectangle. This rectangle would look like this. You don't have to draw this part on if you don't want to. But the area of that rectangle, the height would be the same as this trapezoid, and this part would be the average of those two bases. The distance across would be the same as that mid-segment. Remember, formula for mid-segment is you average those two bases. So I usually don't like to memorize just a bunch of formulas for the sake of memorizing formulas, but these formulas are important that you know them. So like when I think area of a trapezoid, I always think to myself, this is the average of the bases, and then you multiply that number by the height. So that might help you to where it's not just like another formula to learn. For a kite, a rhombus, or any quadrilateral with perpendicular diagonals, they all have the same formula. The area equals half of the product of the two diagonals. And this is essentially the triangle formula, just written differently as well. So I'll explain how it's like the triangle formula, and then you can either think of it that way or you can think of it this way, it doesn't really matter. So do you guys see that like for this rhombus, we have two triangles? Yeah, Abby?
Is it 1/2 of like the final?
The whole diagonal.
Okay.
Yeah. So what we have here is we have this triangle. The base of this triangle is the same as this diagonal, and the height of this triangle is half of that diagonal. So if I wanted to write that out, I could, but then just look at this one. For this triangle, that diagonal is the same, and then the height this way is the same as that other half of the diagonal. So the formula for area of a triangle is half. That's where this comes from. If you think about like taking these two areas and putting them together, you have this diagonal times that one. Yeah.
Wait, say that again, that you like you just said.
So
It's basically like taking these two triangles and putting them together,
it's
and like adding their two areas together.
So it's only half of diagonal 1.
Well, I mean, it's half of the whole product. So just like when you do area of a triangle and you're thinking like half of 3 times 4, well, you have multiple ways of representing that. You can do half of 3 and then multiply that times 4. You can multiply these two together and take half of that. You can do half of 4 and then multiply by 3. You know, multiplication being commutative, as long as you multiply by half, you're all set. But you don't want to take half of this one and half of that one and then multiply. Does that answer your question?
Yeah.
Okay, so same thing here. We have these two diagonals. If you multiply those together and take half of it, that would be your area of this kite. Or, you know, it could be just any quadrilateral. It doesn't have to be like a specific kind with perpendicular diagonals would have that same formula.
So it's like that.
The dotted lines are the diagonals.
Okay. I
They
was-
might be written in there, or they might be written off to the side like this. You're gonna see some examples of some specific questions, and we'll look at
I was
those.
thinking this, you know, like the triangle.
No, these would be
You know, like the egg.
the diagonals.
Okay.
Good question.
That makes more sense.
Good. Okay, so all of these are going to say to find the area of the shaded shape. In this case, this looks like a little razor blade. The dimensions it says are 3, 2.5, and 1. So this is a trapezoid. I'm using that formula for area of a trapezoid. It's half the sum of the bases, so 3 and 2.5, and then you're multiplying that by the height. So when I'm typing this into my calculator, you're just going to end up taking half of 5.5. This one here would be 2.75, and that's square centimeters, because we're talking about area. Okay, for this next one, you don't have both bases. Remember, the bases of the trapezoid are the ones that are parallel to each other. You don't have this base here. You're going to need to find that before you can find the area of this trapezoid. So when I'm looking at this, we have some options as to how we want to do this. We could use the trapezoid formula, which is what I'm going to show you, but you could always break this down into two separate shapes, find the area of each half or each part, and then add them together. Okay? Either way, though, I need to find this. Any ideas as to how I could do that?
Could you like draw where the triangle side is, like go straight down?
I would go straight down here.
So then you can find the bottom part.
Good. So you know that that's 4 already, because that height off to the left-hand side is 4. And then maybe you even notice here that then this would be a right triangle. This is a special Pythagorean triple right triangle. How long is this side? 3. It's a 3, 4, 5. If you didn't recognize that, you could always set it up as x squared plus 4 squared equals 5 squared and solve that for x. A mistake sometimes students make is they think, oh, well, this just is half of 9. Well, you don't necessarily know that, and things don't have to be drawn to scale. So if this part's 3, how long is this part? 6, which makes that other base 6 also. So we have a little work here we have to do first. Area of the trapezoid is half the average of the two bases, or half the sum of the two bases, so that's going to be 9 and 6. And then multiply that by the height. Make sure the height's the one that's perpendicular to those bases, so the height would be 4. So what do you get? What would that answer be? What would it be? Should just be 30, and that's square feet. So any questions on that? Okay, let's move on then. So we have these two shapes. These are both kites and rhombi. Both of them have perpendicular diagonals. This formula works with everything with perpendicular diagonals, so you could even apply it to a square if you wanted to. Like if you had the diagonals in a square, you could use this formula also. Here they just give me both diagonals. So the area is half the product of the two diagonals, so that's going to be 12 and 7. So that would be 42 square feet. To do that in my head, I would do half of 12 and then 6 and then just multiply that by 7. Okay, for this next one, they don't give you the whole diagonal, but they give you enough information that you can find the whole diagonal. So what this is trying to reference is that this part here is 7. So then this part over here would also be 7. So that whole diagonal is going to be 14. And then this part here would also be 9. So that whole diagonal would be 18. So you should get 126. Make sure you're including units on those. This one here should be square inches. Questions on those? No? Okay. Okay, for this one here, it says one diagonal of a rhombus is half as long as the other. If you want to draw a picture for this, you can. You have one diagonal half as long as the other diagonal. Something maybe like that. You have this rhombus. Let's call one diagonal x. I made that one my short one. So what's that other one going to be?
That's
2x. Okay, if you wanted to, you could say that this one is half x and this one is x. Or you could say one is 6x and the other one's 3x. You just need that relationship with the one to be half of the other one. Okay, I'm going to use x and 2x because I have one diagonal half as long as the other. Then I don't have to deal with fractions and don't have to worry about it that way. The area is 64 square inches. So I'm going to plug this into the formula for area. So 64 equals half of x times 2x. When I'm simplifying this then, this would be 64 equals x squared, or x equals 8. To answer the question then, it says what are the lengths of the diagonals? These diagonals would be 8 and 16. Make sure you include units on those. Those would both be inches. When I get done with questions like this, I always like to go back and reread it and make sure that this makes sense. Do I have one half as long as the other? Yes. And then do I also have that the area of these would be 64? If you take those and plug them back in, it's half diagonal 1 times diagonal 2. Questions there? Okay, and then these next ones, it says use algebra to find the given area. For this one here, it gives me the area is 92. So the formula is 92. The area equals half of the product of those two diagonals. The diagonals being 22 and x. So I'm just going to go through this and solve for x. So 92 divided by 11. And we're just going to have to round this. So x is approximately, we'll say, 8.4 inches. For this next one, the formula is area equals half of the sum of the bases. So that would be x and 11, and then multiplied by the height. So you have a lot of different choices as to exactly how you want to work out the algebra for this. Depending on how you want to do it, you could distribute. If you're going to distribute, I would get rid of something first, because otherwise you're going to have to distribute the 1/2 and distribute the 13. So you have some choices as to what you do here. If you would like, because multiplication is commutative, I would probably multiply the 1/2 and the 13 to get that this would be the same thing as 177 equals 6.5 times x plus 11. Then if you want to distribute, you're only distributing one number. Okay, you could at this point also, if you wanted to, divide by 6.5, or you can distribute. So how about this? You guys finish solving this the way you'd like to. I'm going to go ahead and divide by 6.5, and then finish solving for x that way. Did you guys get about 16.2? Yeah? Any questions as to how you get 16.2?
I got it.
Good. Okay, and I think we just have one left. Is that correct? Huh. There it is. Okay, for this last one it asks, what is the height, or sorry, what is, let me start over. Okay, for this last one it asks, what is the area of the kite shown? We don't know the area. We don't have actually either diagonal, so I have some calculating I'm going to have to do first. Perimeter would be very easy. Okay? So I'm going to need to use Pythagorean theorem to find these different amounts. I'm going to set this one up here as x squared plus 6 squared equals 10 squared. Yep, I would do that. Did you push the wrong button on your calculator? Okay. So this part here would be 8. That's going to make this part here also 8. So one of those diagonals is 16. And then I'm going to set this up with the Pythagorean theorem again as y squared plus 8 squared equals 17 squared. So y equals 15. Both of these were Pythagorean triples, and if you recognize those, they make things really quick. If you don't recognize those, you can always go through the Pythagorean theorem. So how long is that other diagonal? 21. So I have half of 16 times 21. The area of that kite would be 168, and that's square inches.